Hello, good evening to this week's problem solving session. Am I audible?
Yes, you are audible.
Okay, thank you. So we'll move on to the problem solving section for today. This is the 6th week of solving session, and we'll be doing the portions that are going to be used for your next assignment, which is basically the 7th week's lecture. Basics on disinfection. Till now, we had done other water treatment processes like sedimentation, coagulation, along with sedimentation and filtration process. Now we are moving to one of the last steps of the water treatment and one of the most important steps of the water treatment process, which is disinfection. And the week 7 will be covering disinfection. A major disinfection technique is chlorination, also other disinfection methods and management techniques on the sludge that comes out once the water is treated, and how that is going to be disposed and how it is going to be managed, and some other miscellaneous treatment processes along with some practice problems. So we'll be doing some sample problems based on the assignment that is based on these lectures. So we shall move on to the questions. The first question is, the primary goal of the drinking water treatment process is complete removal of total solids, or is it removal or inactivation of pathogenic microorganisms, or is it complete destruction of all microorganisms, or is it all of the above? Sangamitra, if you're free, you can just switch on your mic and tell the answer. Give an answer, or you can use the chat to give in your answer.
I think it is B.
Removal or inactivation of pathogenics. Yeah. Right. So primary goal of drinking water is always to remove the biological impurities in water that is disease causing. So in water treatment, either removal of these pathogenic microorganisms or completely inactivating it or killing it, destroying the entire organisms is one of the most important steps of or important objective of water treatment process. So both in the case of surface waters as well as groundwater, whatever solids we remove, whatever chemical substances remove, it might not have an immediate effect. Maybe accumulation of all these impurities in water might be harmful to our body, but pathogenic microorganisms in water, if it is contaminated, it will definitely cause waterborne diseases, which is a condition that cannot be tolerated at any level in the purposes of drinking water. So disinfection and removal of these microorganisms, particularly pathogenic microorganisms, is one of the major objectives of water treatment process. So the answer you said is correct. It is removal or inactivation of pathogenic microorganisms. Now the second question, there are few diseases given and certain categories of waterborne diseases given. So match the following with each other and choose an appropriate option. You can either switch on your mic and tell the answer, or you can put it in the chat box. Either way, sir, fine. This is for the new participant in here, Mujahid, I believe. Okay, Mujahid has said it's D. So I think I'll move on to the answer.
I'm confused between A and C.
A and C. Okay, okay. I will move to the answer, then we'll be able to. So there, like we had seen in the question, there are 4 categories of water-related diseases with the following names: waterborne diseases, water-washed diseases, water-based diseases, and water-related vector-borne diseases. Now, what are waterborne diseases? These diseases are infections that are spread through contaminated drinking water. If the water is consisting of pathogenic microorganisms, then if you drink that water, then infections that spread through such contaminated water is called waterborne diseases. Majorly bacterial infections and all, typhoid fever and all is caused because of is a waterborne disease. Now, what is water washed disease? Water washed disease is a condition that is occurring when places that are having insufficient supply of clean water, what happens is proper sanitation or hygiene goes missing, or since there's a lack of water, properly washing the hands or bathing or keeping the surroundings clean becomes a problem, as a result of which there might be diseases that are caused because of unhygienic conditions. So diseases that come under such a criteria are called water washed diseases. Such diseases are also called as water scarce diseases because of the insufficient supply or insufficient what to say, availability of clean water, and because of that there is lack of proper sanitation and hygiene. Diseases might occur, and such diseases come under water washed diseases. Like you can see in the slide, some of the fungal infections and all are happening because of unhygienic when we don't maintain proper hygiene. So such diseases come under water wash diseases. Now, what are water based diseases? Water based diseases are diseases that are caused by aquatic invertebrate organisms like parasitic worms. This disease called schistosomiasis, it is caused by a parasitic worm. This parasitic worm lives in when it is in its larvae form or egg form, it is consumed by snails present in water. So these inside the body of the snails, this worms will develop, and after they develop, when the development stage is over, it will get again pushed onto this water, and through this water again, when it enters the body of a mammal, which is the body for its survival, it will cause diseases like this disease is caused, and such diseases are coming under water based disease. So here parasitic worm and snails majorly are actually helping in the development of these parasitic worms. So that is why this disease comes under water based diseases. Now the fourth category is water related vector borne diseases, is like insects like mosquitoes. When there are stagnated water, these mosquitoes are going to lay eggs in it, and these are going to develop. The propagation is occurring through stagnated water bodies, and the diseases caused by such insects will come under the category of water related vector borne diseases. So all disease, most of the diseases caused by mosquitoes are coming under this water related vector borne diseases. So in this question, if we go by the options, water borne diseases is typhoid, water washed diseases is ringworm, water based diseases is schistosomiasis, and water related vector borne diseases malaria. So the option A is the correct answer. 1C, 2D, 3B and 4A. So that's about the different categories of water related diseases. So moving on to the third question. Disinfection is typically preferred over sterilization in water treatment because of, what are the reasons why disinfection is preferred over sterilization? Is it because sterilization is a far more expensive process than disinfection, or is it because disinfection is providing more safety from the risk of waterborne diseases, or is it because it is killing all the microorganisms that are even present, that are even useful to humans, or is it all of the above? Kiran and Mujahid, you can also share your answers in the chat box. Okay, so Mujahid has said D, Sangamitra has said B. Let's see what the answer is. So before we move on to what is why it is better or why each of the processes are better, let's try to understand what is the difference between disinfection and sterilization. So disinfection is a process that is killing the pathogenic microorganisms in water. It is only killing the unwanted microorganisms in water, whereas sterilization is a process which will kill every organism that is present in water. Not only the pathogenic microorganisms, if there are spores, if there are any other microorganisms that are useful to humans, all the biological organisms in water will be removed through the process of sterilization. Whereas in case of disinfection, only the pathogenic microorganism, we are just focusing on removing or inactivating or killing pathogenic microorganisms in water that is going to cause waterborne disease. So definitely disinfection is preferred over sterilization in terms of water treatment. Why? Because our major aim is to remove pathogenic microorganisms from water. So as the points in here says, it is resulting in complete destruction of all microorganisms. It is also more expensive, and in terms of water treatment, it is not necessary. Sterilization is a process that needs to be followed when in medical fields, medical intensities, because in medical situations during surgeries and all, there is high risk exposure of our blood to microorganisms can be high risky situations. So in such conditions, sterilization processes are very important. But in terms of water treatment, sterilization is not necessary. We can achieve our objective through disinfection itself. So waterborne diseases can be obtained through, waterborne diseases can be eliminated through the process of disinfection. So that is why disinfection is preferred over sterilization when it comes to water treatment. So the answer for this question is all of the above. It is, since sterilization is far more expensive than disinfection, it is providing adequate safety from risk of waterborne diseases, and sterilization sometimes also kills the microorganisms that are necessary for humans. So all of the reasons are, all of the above is the reason for preferring disinfection in terms of water treatment. So that was about this question. Moving on to the fourth question. Which of the following is not a chlorine-based disinfectant? Is it chlorine gas? Or is it chloramines? Is it chlorine dioxide? Or is it chlorine trifluoride? Okay, so two of you have given the answer as D, which is the right answer. Let's see some details on it. So there are various methods of disinfection, and chlorination is one of the most commonly used or most generally used method of chlorination. It is a chemical method because we are making use of the chemical chlorine. So in chlorine, when we are doing chlorination, we used a lot of chlorine products to do the disinfection. So out of that, few of the examples are chlorine gas, chlorine hypochlorite. Chlorine hypochlorite is obtained when chlorine, that is elemental chlorine, is mixed with water. Sorry, not elemental chlorine. Cl2 is mixed with water. It will dissociate to form hypochlorous acid. And hypochlorous acid, HOCl, is the chemical formula for hypochlorous acid. Hypochlorous acid, since it is a little unstable, it will dissociate to form hypochlorite ions, which is also a byproduct of chlorine. So chlorine gas, chlorine, hypochlorous acid, hypochlorite ion, chloramines. Chloramines are formed when chlorine reacts with ammonia and water. Chloramines are formed. So that is also one disinfecting product of chlorine. And chlorine dioxide are some examples of forms of chlorine that is used for the process of disinfection using chlorine. So in this question, chlorine trifluoride is not a chlorine-based disinfectant. It is one colorless poisonous gas that is not used as a disinfectant. So one of the important topics in disinfection is chlorination. So it is good. It is important that you know what are the different types of products of chlorine that are used in disinfection, and be familiar with the different products. There's chlorine gas you can use. There is hypochlorous acid, hypochlorite ion, chloramines, and chlorine dioxide that are used for disinfection when you consider chlorine as a disinfecting agent. Okay, so let's move on to the next question. Which of the following disinfectants provide a residual to ensure future protection? Future protection. Protection, sorry. Is it UV radiation? Is it ozone, chloramines, or boiling? Okay, Sangamitra and Kiran has given the answer. Mujahid also has given the answer C, which is the correct answer. So let's see what residuals is. Residuals is nothing but when you put this product into water for chlorination, some reaction is going to happen and some byproduct is going to be available in water, which is also going to help in disinfection in the future. So this is what is called a residual in terms of disinfection. So when you boil, you're not getting any residual which is useful for disinfection. When you use ozone also, you do get bromide as sometimes as the residual, but then again that is a very reactive thing and it doesn't stay in it. So we don't consider it as a product or as a chemical that helps in getting residual. UV radiation, of course, there is no residual formed when you use UV radiation, but out of the options given, chloramine is something that will help in producing a residual which is going to help in disinfection in the future. That is the chemical reaction that is occurring in the water. Chloramine is going to produce a byproduct that is going, I mean, residual in the future that can residual which will help in disinfection in the future. All products of chlorine, that is pre-chlorine, chloramines, chlorine dioxide, some or the other form of residual they'll form. But then ozone, UV radiation, and boiling is not going to provide any residual. So the answer is chloramines. Although whatever they're producing, although chloramine in comparison to the other chlorine products are a weak disinfectant, when you compare it to other chlorine products, it is producing, the residual that it produces is very stable. So this will help in future disinfection process of the water. So that was about residual and what techniques of disinfection are helping us to obtain residuals. Now moving on to the sixth question. A first order degradation model is typically used to denote the disinfection kinetics of the death of microorganisms. Which is the correct expression explaining the disinfection kinetics? If N is the number of viable microorganisms remaining and T is the time taken. Kiran and Sangamitra has given the answer C, which is the correct answer. So we know that when disinfection happens, what is happening? Death of microorganisms are happening. And that is with respect to time, there's a decline in the amount or the number of microorganisms present in water. So it is a decreasing first order decrease, the rate of that is a number rate of the change of number of microorganisms in water is going to decrease with respect to time. So here also, if you can see, this is the third equation, that is dN by dt is equal to minus Kn is the equation that is depicting the decrease in the number of remaining viable organisms in water. You can also see the slides and read a little more about it, about this disinfection kinetics. It is a first order reaction with respect to time. And then when you integrate it, you get an equation which is known as the Chick's law. This is describing the describing the rate of decrease of number of microorganisms in water as a result of disinfection. dN by dt is equal to minus Kn. It is good to know this reaction, or it is good to know this equation, and also what is the name of this law that is derived by integrating this equation with respect to time. So that was about the sixth question. Now you can see here, there's a graph given with the percentage of residuals and pH in the x-axis. So which chlorine residual form, A, B, C? You have the initial portion A, the middle portion B, and third portion C, and the pH at which these are existing. So what is A, B, and C representing? A, B, C are chlorine residuals that are formed. Which kind of chlorine residuals are formed in the following regions is the question. All of you, maybe be good if you all give it a shot. Now I can say HOCl means it is hypochlorous acid. Cl2 is chlorine. OCl minus is hypochlorite ion. Kiran Mojahid said it's B. Okay, I'll move to the answer. So you can see over here, this is giving us the free chlorine residual with respect to pH. So if you see, when the pH is at a value that is at 1, which is less than 5 or less than 4, you see that free chlorine is available as Cl2 in water, and this is what is acting as the disinfecting agent in this pH value. That is pH less than 4 or pH less than 4, chlorine is available as the disinfecting agent. Now, when the pH increases to around 8, what happens is chlorine will react with water to form hypochlorous acid, which is HOCl. So when the pH of the water is between say 3.5 and 7.5, chlorine exists in the form of HOCl. That is a stable form of chlorine in that pH range. Now again, if the pH of the water is increased from 7.5 to above, like 10 value, hypochlorous acid is going to dissociate into hypochlorite ion and H+. So this is actually giving us an idea the form of chlorine that is existing at different pH values. So at a pH less than 4, the chlorine exists as the chlorine gas itself or chlorine molecule itself. At a pH that is greater than 4, in between till 7.5. Less than 7.5, it is existing as hypochlorous acid, which is HOCl, and at a pH that is greater than 7.5, it is existing as hypochlorite ion, OCl minus. So the correct answer for this question would be A. So B. This region is having chlorine at chlorine. This is having hypochlorous acid, and this is having the hypochlorite ion. So this one, these three things and the reaction and the pH at which it exists is also very important with respect to this disinfection and chlorination portion. At what pH does chlorine is chlorine available in its own form? At what pH is it being dissociated to hypochlorous acid? At what pH is hypochlorous acid is being dissociated to the hypochlorite ion is one important portion in this chlorination part of chlorination. So this is also something that you need to have a focus on. Majorly, hypochlorous acid and hypochlorite ion are the major compounds when you pass chlorine into water. It is hypochlorous acid and hypochlorite ion that is accomplishing the disinfection. Hypochlorous acid is the most powerful of the free available chlorine. That is, hypochlorous acid. If you compare hypochlorous acid, OCl and Cl2, hypochlorous acid is the most powerful, has the highest strength in disinfection. After that, only OCl minus is strong. So, in case we need good disinfection, it is necessary that we maintain the pH of water less than 7.5 and something in between 4 and 7.5, so that we can get maximum efficiency in disinfection, because hypochlorous acid is what is the most powerful disinfecting product. Now again, this is a question that is talking about disinfection byproducts, formation of disinfection byproducts. Which of the following disinfectants here has the least tendency to produce disinfection byproducts? Is it UV radiation, chlorine dioxide, ozone, chlorination, or chloramination? Which out of the following has the least tendency to produce a byproduct, disinfection byproduct, a byproduct that can help in disinfection? Yes, Kiran has given the answer A. Mujahid C. Okay. Okay, let's move on to the explanation that will give better clarity on this question. So if you see here, UV radiation actually produces no byproduct. Like earlier we said, chlorine products are going to give some or the other kind of byproduct. So chlorination and chlorine dioxide is out of question. Ozone is going to produce some residual, that is in the form of bromate, but high bromide concentration. But again, it is, since it is very unstable, it is not going to last in water, but even then it is going to produce some byproduct over there called bromate, which is going to help in disinfection. Chloramination, chlorination, and chlorine dioxide is definitely producing some or the other byproduct of chlorine that is going to help in disinfection. But out of these five, UV radiation is going to produce no disinfection byproduct. The question was disinfection byproduct, not any byproduct. Disinfection byproduct, that is a byproduct that will help in disinfection. So in the five options, UV radiation is not going to produce any byproduct. Chlorine dioxide is going to produce chlorate and chloride. Then ozone is going to produce bromate. Chlorination is going to result in the formation of trihalomethanes and trihaloacetic acids. And chloramination, that is making use of chloramines, is also going to result in byproducts. If you see this chart, it is based on all this that the disinfectant is chosen, whether how much of residual is formed, what all pH is it active in. It is based on this that disinfectants are chosen for the process of disinfection. So if you go through the slide, you can know what kind of water or what kind of standard, what type of agent we should use. Should we use a chlorine gas? Should we use chlorine dioxide, chloramine, ozone, or ultraviolet radiations for disinfection process? Okay, so moving on to the next question. Photocatalysis, sonolysis, and electrochemical oxidation are different types of. Are these examples of membrane process, electrodialysis process, advanced oxidation process, or adsorption process? Kiran has given C. Okay, let's move on to the explanation. So photocatalysis, sonolysis, and electrochemical oxidation are processes that are coming under advanced oxidation processes. Now, what is advanced oxidation process? Advanced oxidation process, it is a chemical treatment procedure to remove organic, sometimes inorganic materials through oxidation reactions of the with the hydroxyl radicals. This is the basic process that is happening in advanced oxidation processes. There are many kinds of processes that comes under advanced oxidation process like ozonation, sonolysis, wet air oxidation, phenton, photophenton, UV based. All these processes, disinfection processes or treatment process is coming under advanced oxidation processes. So here also in the slide you can see what are the different kinds of advanced oxidation processes: photocatalysis, sonolysis, phenton based, photophenton based, ozone based, electrochemical oxidation, and some other AOPs are wet oxidation, supercritical water oxidation, electron beam irradiation, and gamma irradiation. It would be good to just have keep in mind what are the different kinds of advanced oxidative processes that is happening. Now, it is basically removing the organic and also sometimes the inorganic materials in water. It's a chemical reaction that is occurring by with hydroxide ions. So the correct answer here is advanced oxidation process, option C. Moving on to the 10th question. Which of the following is a major disadvantage of typical membrane-based processes? Is it production of highly polluted water, demineralization of treated water, fouling and frequent replacement, or is it all of the options? Sangamitra says it's C. Mojahid is also saying it's C. Kiran, do you have an answer? Okay, Kiran is saying it's D. So let's move on to the solution. So membrane process is nothing but making use of a membrane for the process of separating out the polluted water or disinfected water and to obtain a better quality water. So what happens in membranes? This is basically, there are many kinds of membrane processes like reverse osmosis, ultra filtration, nanofiltration, and all of these makes use of membranes, and based on the size of the membranes, the classifications are done. Now, some of the advantages of the membrane-based processes is, since the units will be compact, it is not making use of a lot of space compared to the conventional treatment scheme. It is a very simple operation. The membranes can be used to separate out various types of contaminants. It's not just, it is based on the size of the membranes and the material of the membrane. So it can be used for a variety of contaminants, and also the necessity of using a chemical is not coming over there. But what is the disadvantages along with the disinfection process or treatment process? It is also demineralizing water. It is also resulting in the removal of certain minerals in water that is useful for us. So that is one disadvantage of it. Not only that, these membranes over time, it is going to be collecting all these contaminants, and then it will result in a process called fouling, which is actually resulting because of the accumulation of the contaminants. So it also needs to be replaced on a regular basis. So that is another disadvantage of this membrane based process. Another disadvantage is the water that is actually passing will be good water, but there will be some amount of water that needs to be rejected. Now, all this rejected amount of water that is containing all the polluted and toxic thing, this is actually this is required to be disposed of elsewhere, and this is going to again pollute the water or pollute the source into which this is going to be rejected. So that is also one disadvantage of this membrane based water. Whatever remaining water is there, it is going to be highly polluted water. So disposal of that and removal of that is again going to create further pollution. So these are some disadvantage of membrane-based processes: reverse osmosis, nanofiltration, ultrafiltration, microfiltration. These are few methods of membrane operation. Now coming back to a question, major disadvantage of typical membrane-based process is all of it: demineralization, fouling, frequent replacement, production of highly polluted water. All of the above are disadvantages of the membrane-based processes. So it's option D. So that was about this question. Now moving on to the 11th question. So before moving on to the 11th question, I would like to talk about sludge thickening and dewatering, or the sludge formation. Now, after whenever all these treatment processes are occurring, what happens is these after sedimentation, you have some deposits at the end. Again, after when the water is coagulated, flocculated, and kept for sedimentation, again there are some semi-solid impurities that is being settled. So this remains are in the form of a thick mixture of solids and water. It is a very thick semi-liquid kind of material, which is called sludge. Now, this sludge also has to be disposed, and even when sludge is being disposed, it is necessary that it is treated to a level such that when the sludge is disposed, that sludge is not going to create any pollution or contamination of the body into which it is being disposed. Suppose you are disposing it into river, the sludge, if it is highly contaminated, we have to do some treatment to remove the contamination before the disposal of the sludge. So it is for this that things like gravity thickness and mechanical dewatering units are used. And what they use is this semi-liquid form of sludge will be there. The sludge, what they'll do is they'll extract the water from the sludge, and they'll concentrate the solids in the sludge into biosolids, and then they'll dispose that separately. And this water, which is called a supernatant, that is, it is a thick mixture of water and solids. This water that is obtained will be again treated to a particular level, so that while disposing it, it will not pollute the source of body into which it is going to be disposed. So this is what gravity thickeners or mechanical dewater or sludge units are doing. So now we are going to a numerical question. So before going into that numerical question, I would like to discuss this question. So discussing this question is going to help you do the numericals that is coming further. So in this question, they are saying that a gravity thickening unit, like I explained, a gravity thickening unit is a process in which the solids are condensed to provide a concentrated solid product, and the liquid, which is a supernatant liquid, we can separately get those two. So this gravity thickening unit is receiving an inflow of sludge, a mixture of the solids and water called sludge. 40 meter cube per day of sludge it is getting, and the solid content in the sludge is 1%. V by V indicates volume of the solids to the volume of the sludge. So 1% of it, 1% of the inflow that is coming has 1% of solid content in it, which is expressed as the volume of the solid to the volume of the sludge. Now, once it is entering this gravity thickening unit, it is able to increase the solid content to 4%. That is, what is happening is they are going to concentrate all the solid in it, and the solid content is increasing to 4% of volume of solids to volume of sludge. Now, what they want is the outflow from the thickening unit is put to a mechanical dewatering unit to increase the solid content to 25%. So from this gravity thickener, what they are doing is they are pushing the that whatever is coming out from the gravity thickener to a mechanical dewatering unit, which is further increasing, concentrating the solid to 25% of the solid content. They want us to determine the sludge volume that is coming out first out of the gravity thickener. That is the flow rate of the or the volume of the sludge that is coming out of the gravity thickener, and also what is the volume of the sludge that is coming out of the mechanical dewatering unit. So I'll go through the question once again. This will take a while for it will take a while for you to wrap your head around this terms like solid content and sludge volume and all. So a gravity thickening unit receives 40 meter cube per day sludge with the solid content as 1%, V by V indicating volume of solid to volume of sludge, and it is able to increase the solid content to 4%. Gravity thickening unit is thickening that sludge into 4% solid content. Now outflow, whatever after all this process, whatever outflow is coming, that sludge is pushed into a mechanical dewatering unit, which is increasing the solid content to 25%. They want us to find the sludge volume that is coming out of the gravity thickening unit, as well as the sludge volume that is coming out of the mechanical dewatering unit. So the data that we have been given here is the inflow sludge. So the total sludge inflow given here is 40 meter cube per day. Now they have said that the solid content is 1% volume of solids to volume of sludge. So if you multiply it with this value, if you multiply this 1% value, that is 40 into 0.01 is going to give us the volume of solids in the inflow. Here, this meter cube per day is giving us the volume of the sludge, that is flow rate of the sludge. And here, this value is giving us the volume of the solids in the sludge per day. That is obtained by multiplying this solid content percentage. Now, same here in the outflow from the thickener, they said the solid content is 4%. So if the sludge volume outflow, if you consider a variable ST, then we can say that 0.04, that is 4% into that outflow is going to be 0.4 into 0.4 meter cube per day. That is, we have already calculated that the volume of solids is obtained in when the inflow gets into this gravity thickener is 0.4 meter cube per day. So 0.04 into the outflow is giving us the volume of the solid content, and when we divide this 0.4 divided by 0.04, we will get the outflow rate of the sludge, that is total sludge outflow. Now we got the outflow of the sludge which they had asked us, the sludge volume coming out of the gravity thickener per day we got. Now they want us to calculate the sludge volume that is coming out of the mechanical dewatering unit. Now in the mechanical dewatering unit, what they have done is they have said that like the gravity thickening unit is concentrating the solid to 4%, this mechanical dewatering unit is concentrating the sludge to 25% solid content. So the same way how we did it in the gravity thickener, given outflow of the mechanical dewatering unit as SD, 25% of SD is going to be 0.4 meter cube per day, because we know that that is the solid content in the water that entered the dewatering unit. So 25% of the outflow is going to be equal to 0.4 meter cube per day. So the SD will be SD obtained here, that is outflow of the dewatering unit, of outflow of the sludge or volume of the sludge that is coming out of the dewatering unit is going to be 1.6 meter cube per day. So this question has been given in the lecture. You can go through it once again, the explanation and everything. I explain this so that we can do the next problem in the same way. So you're multiplying the solid content with the inflow sludge volume to get the volume of the solids. And then in order to get the outflow, you're again multiplying the solid content percentage with the outflow rate, which will give us a volume of the solids which we already have. So this is our question. You can read the question, take your time, think about it, and then try the answer and give me a response as to go ahead, so that I can move on to the solution. Those of you who want to try, you can give it a shot and then let me know. I'll go to the explanation. The volume of sludge produced per day in meter cube per day is what they're asking. They're saying they're producing 3,200 kilogram per day solids. Here they have given us the solids amount, that is 3,200 kilograms of solids are produced in a day with a 2.5 percentage weight by weight solid content. Earlier, if they had given us V by V, here they have given 2.5 percentage of weight of the solid to the weight of the sludge. Is the percentage value they have given, and a value of bulk density is also given. If you go by the units itself, you will be able to solve this problem. So give it a shot and let me know. I'll move on to the explanation. Mujahid has said 0.142 million liters per day, and Kiran has given 115.3. Sangamitra, if you are doing, if you can just respond, I'll wait for it.
Yes, I'm doing.
Okay, then I can wait for you. Shall I move on to the solution?
Yes, continue.
Okay. So, like the earlier problem, Kiran, your answer was right. It is 105.315 meter cube per day. Now, as you can see here, the weight of the solid in the sludge is given. Earlier we had computed it, but here it is already given. 3,200 kilogram per day is the weight of the solid in the sludge. Now they have said that the sludge solid content in the sludge is 2.5 percentage weight W by W, which it means that 2.5 percentage of the total sludge weight of the sludge uh, is solids. So when you multiply it with the total weight of the sludge, you will get the weight of the solid. Now we have been given the weight of the solid is 3200. So 0.025 into the total weight of the sludge is giving us 3200. So when we divide 3200 by 0.025, you will get 1,28,000 kilograms per day. Now, that is again, you can see weight of the solid is in kilogram, weight of the sludge is also in kilogram. Into kilogram per day, you will get weight of the solids as 3200 kilogram per day. So the total weight of the sludge we obtained this one. Now they have asked us to find us the volume of the sludge. So since they have given us the bulk density as 1.1 kilogram per liter, when we divide the weight of the sludge, which is 1,28,000 by the bulk density, we will get the volume of the sludge in liters per day. When you convert it to meter cube per day, it will give us 115.315 meter cube per day of sludge from the treatment plant. So this is another version of the question that we discussed earlier, where they had given us the volume. Here they have given us a weight. So the weight again in the end, when we divide it by the bulk density, is giving us the volume of the sludge in meter cube per day. So moving on to the next question. Again, in the previous question, we got the answer as 115.315 meter cube per day. Now, the volume of the sludge produced, they say that it has solid contents of 0.9%, and then when it is treated with the sludge thickening unit, the solid content is increasing to 3.7%. What is the percentage reduction in the total sludge volume? Again, this is a very simple numerical. We've been given the volume of the sludge, which is nothing but 115.315. You can take note of it. 115.315 meter cube per day is the volume of the sludge produced in question number 11. And it has a solid content of 0.9% in this question. When this is fed into a sludge thickening unit, the solid content is increasing to 3.7%. The question here is, what is the percentage reduction in the total sludge volume? So we can find out the outflow sludge volume. We know the inflow sludge volume. We can find out the outflow sludge volume from the percentages of the solid by first computing the volume of the solids, and then computing the volume of the sludge from this volume of the solids, and then minusing or finding the difference between the outflow sludge volume and the inflow sludge volume. You can give this a shot. I can give you 2 to 3 minutes to do this problem. Read the question carefully and try solving it. It's 115.315 meter cube per day. Okay, Kiran has given 75%. Any more answers?
Ma'am, good evening. I had one ma'am question.
Yeah.
Ma'am, actually assignment number 5, if you don't mind, I got different answers and ma'am, did you try assignment number 5? I was getting different answers.
Which assignment number 5? Can you just tell me what portion it is dealing with?
Ma'am, sedimentation tank. So they had actually not told the depth and the length, breadth, depth. They had not told. They just gave 3 numbers. So we had to take the breadth and depth.
Okay.
So when you take the breadth and depth as different numbers, 4 and 4.4 meters may confusion tha. So you will get different answers.
Okay, which question number is it?
It is 11. 11 and the numericals. I got different answer for 11, 13 and 15.
Okay.
When I was getting the taking the breadth different, breadth and depth different.
Did you try swapping the breadth and depth? I mean, if they have not specified, did you try changing the numbers?
And if I swap, then I'll get the answers as per the correct answers given in the.
Okay, so you're saying that they have not mentioned correctly which is breadth and which is depth. Okay, I'll look into it. Like by the end of the session, we'll have some time left, so we'll I'll just look into it. And
thank you.
Okay, so let's move on to the answer. So, like in the earlier we have discussed, we had got the total inflow sludge volume as 115.315 meter cube per day. So the volume of the solids can be obtained by multiplying this percentage of solid content with this volume, which is 0.9 percentage, which is equal to 0.009. So here we are getting 1.037 meter cube per day is the volume of the solids. Now they have said that when the water is going into the sludge thickening unit, it is increasing the solid content to 3.7%. So 0.037 into the outflow of this water is giving us 1.037 meter cube per day of solid volume of the solids. So the outflow can be obtained by dividing this value by the percentage 0.037, which is 28.049 meter cube per day. So we got that value. In order to get the reduction in sludge volume, we have the inflow sludge volume, we have the outflow sludge volume. When you find the difference between the two, it is 115.315 minus 28.049 divided by 115.315 will give us 75.676%. Kiran, your answer was right. It is around 75 or 76%. The percentage reduction in the total sludge volume. So if you check the practice problem in the lecture provided and these two problems, I believe it will be sufficient with regard to this sludge thickening unit and to understand the solid contents and the terms required for this kind of numericals. So do go through it in detail and this will help you solve problems if in the assignment also. Moving on to the 13th question, we are going to the process of chlorination, chlorin dose, chlorin demand. Here they've asked to determine the chlorine dosage if the CT value is nothing but the concentration of the residual chlorine into the time of contact. C is the concentration of the residual chlorine into time of contact value. Sometimes disinfection is expressed in terms of CT, and that is given as 62 milligrams per minute per liter. Milligrams into minute per liter. And 5 mld of water is to be treated in a tank of volume 15 meter cube. What is the chlorine dosage in milligram per liter? Again, this is a question you will be able to do if you are familiar with the units. I mean, if you play around with the units, you will be able to do this problem. So maybe give it a try and then we'll go into the explanation of this. Okay, so this is if you're familiar with the terms, this is something that you can do very easily. Let's move on to the explanation. So the CT concept is nothing but, like I told, sometimes disinfection is expressed in terms of CT. CT is nothing but C is the concentration of the disinfectant and T is the contact time. Contact time is the time that is required for the disinfectant to be in water so that the disinfection process will take place efficiently. So it is sometimes represented in terms of CT. Now, the question over here, like you can see here, there are certain set CT concentrations, and if you refer to the slides, you can read more about it or understand more about it. In terms of this numerical, they have given us the chlorine dosage. Now, what is the difference? There are three important terms when you do the chlorine dosage, chlorine demand, and problems. So, chlorine dosage is the amount of chlorine that is required to do effective disinfection of water. So, disinfection of water does not just mean killing the microorganisms, but it is also necessary that a certain amount of residual chlorine remains in water for future disinfection. So chlorine dosage is that amount of dose of chlorine that is required to meet the demand of disinfection plus the requirement of residual chlorine. That is a reaction that is required to form some residual chlorine. Both together, what is the dosage of chlorine that will help us in acquiring this amount of chlorine or this amount of reactions is called as the chlorine dosage. Now, in term, we can come to the further explanation we can come to in the following slides. So in here, they have given us CT value. CT value is 62 milligrams minutes per liter. They have given us the inflow rate. They have given us the volume of the tank. So we can, from the flow rate, we can, when you convert it to meter cubes per day, you will get 205,000 meter cube per day. Again, when you convert it to meter cube per hour, you will get 208.33 meter cube per hour. Now, contact time can be obtained from this flow rate and the volume of the tank by dividing the volume of the tank with the flow rate. So that will help us in getting the time required for this, the time in for which the water will be in this tank for the disinfection to happen. So that is 0.02 hours, which is 4.32 minutes. Now, since we have the CT value, if you divide the CT value with this contact time, you will get the concentration of chlorine that is required to be applied into water, or whatever chlorine dosage, which is 62 divided by 4.32 gives 14.35 milligram per liter. Kiran, again, your answer is right. This will be the chlorine dose computed from this data that is provided. Now, I had told about this chlorine reaction. So, when you see here, what happens is when chlorine is put into water, first itself it doesn't start disinfecting. What happens is chlorine will first react with these iron, manganese, and sulfide. After that, it will react with ammonia. It will form monochloramines. It will form dichloramines. And after that, after all these reactions happen, it will start forming residual chlorine. If you can see, the chlorine dosage is the amount of chlorine that is required to meet the chlorine demand as well as for chlorine residue.
Actually, your voice is not audible to me. I don't know it is in my case or in case of others.
Hello, am I audible now?
Yes. Now you are audible.
Okay. Sorry about it. So I was talking about the terms chlorine dose, chlorine demand, and chlorine residual. So this is an important formula. If you can actually read about chlorine dose, chlorine demand, and chlorine residual, but in numericals, this is always asked. Chlorine dose is going to be chlorine demand plus chlorine residual. Chlorine demand is nothing but all these reactions that are occurring in the water into which chlorine is put. So initially, in order to remove these inorganic compounds, the chlorine will react. After that, it will start undergoing some reactions until it will form chlorine residual. So the amount of chlorine that is required to do all these reactions with inorganic and organic materials in the water as well as form free residual chlorine is called the chlorine dose. So it is not just enough if you put that is what I had told in the beginning. It is not enough if you just put it for disinfection. It is also required to meet the need of residual chlorine. That is the optimum amount of chlorine dose. So, when we move to this question, in this disinfection process that we have told in question number 3, it is resulting in 1.35 milligrams of residual chlorine. So, what is the value that is being provided here? Chlorine dose. So we have got the value for chlorine dose is equal to 14.35 milligram per liter. Here they have given residual chlorine is equal to 1.35 milligram per liter. They are asking us to find a chlorine demand. So using that formula that I just now told, it is very simple to calculate what is the chlorine demand. Chlorine dose is equal to chlorine demand plus residual chlorine. So just do the calculation and let me know the answer. The 14.35 milligram per liter is the chlorine dose. Okay. So like I said, chlorine dose is equal to chlorine demand plus chlorine residual. So please be careful with this chlorine dose and the chlorine demand. Even I make the mistake sometimes. I get confused between the dose and demand. So chlorine dose is the requirement of chlorine to fulfill all these reactions that is occurring in water along with formation of residual chlorine. Chlorine demand is only the amount of chlorine that is required to I mean, for all these reactions to happen, what is the chlorine amount required is the chlorine demand. Chlorine dose, that is optimum dose for disinfection to occur, is the chlorine demand plus chlorine residual. So residual chlorine, after a point of time, again there is disinfection, I mean the contamination process can occur. So in order to take care of future requirement, this residual chlorine is necessary. So this is another problem that is, we'll come back to it. Here the answer is 13 milligram per liter. Like I said, chlorine dose is equal to chlorine demand plus chlorine residual. So chlorine demand is equal to the dosage minus the chlorine residual. So it is chlorine dose was given in the question number 13, and we found out chlorine dose in question number 13. And here the residual chlorine is given. So if you minus the chlorine residual chlorine from the chlorine dose, you will get the chlorine demand. This is another problem in the practice. This one, they have given this much of weight of chlorine to treat this much of water. Residual for 30 minutes contact time is 0.15. So they have given us the residual chlorine value. They have asked to find the chlorine dosage and the chlorine demand of water. So chlorine dosage, you can obtain it because they are using this much amount of this much weight of chlorine is given. So when you multiply it with the inflow rate of water, you're actually getting kilograms into milliliters. Yeah, when you convert the units, you're getting the chlorine dose. Again, by using this formula, you can get the chlorine demand. So this is also one important part of this chlorination portion. Finding out chlorine dosage, finding out chlorine demand. They'll give either of the two values and they'll ask you to find the chlorine dosage, or they'll give the weight of the value, amount of water flowing into the tank, and they'll ask you to find the chlorine dose and chlorine demand after giving residual chlorine value. Now going to question number 15. This is based on reverse osmosis. So reverse osmosis is a process in which through the process of reverse osmosis of water, we know osmosis of water, through the reverse osmosis process, water is treated. So in this treatment unit, they have installed it to treat 12 million liters of water per day, and the total dissolved solids is 1500 ppm, which is 1500 milligrams per liter. They've asked us to determine the total dissolved solids in the RO reject. RO reject is nothing but after the water is passing through the membrane and the reverse osmosis is happening, there's another polluted or rejected water which is concentrated in the total dissolved solids, and the non-concentrated water is going to go out of the treatment unit. So that reject, they have asked us to find out the TDS in the reject water. If the level of TDS in treated water is 40 ppm, that is in treated water, the amount of solids that should be available should only be 40 milligram per liter. And they have also said that the RO unit is rejecting 40% of the flow. So only 60% of the total flow is coming out, is being treated and coming out. Remaining 40% is being rejected. So we know out of the total water that is entering the tank, 40% is going into the reject. We have to find the total dissolved solids in the reject water. In case of treated water, they have given us the amount of total dissolved solids, and 60% of the water is being treated. It's coming under treated water. So what will be the TDS? Again, if you play with the units, you will be able to get the answer. You can give it a try and wait for 2 to 3 minutes. Okay, so I'll move on to the solution. So like I said, if you see words like reject and permeate, it is nothing but in the reverse osmosis. What will happen is the membrane is going to reject after the osmosis process happen. Some amount of water is going to be there, which is rejected out. This is consisting of the concentration of contaminants or impurities that are removed through this process. So in here, we have been given the inflow rate, which is 12 into 10 to the power 6 liters per day of water is going into this treatment plant. So from this, they had said 60% of the water is being treated, 40% is rejected. So we have that quantity also. Secondly, they have said that the total dissolved solids of the inflow water that is coming is 1500 ppm, which is nothing but 1500 milligrams per liter. So total dissolved solids in the inflow rate can be obtained. That is the weight of the inflow total dissolved solids can be obtained by multiplying this value into the inflow rate, which will give us the value of the total dissolved solids weight of the solids in water per day. Now they have said that the TDS in treated water is 40 milligram per liter. That is, they only want 40 milligram per liter, and they have also said 60% of the water is being treated. So in the 60% of the water that is being treated, if you multiply it by 40, we are actually getting the TDS required in the outflow. Now another quantity that they have given is 40% is in the reject, and they have also given the weight of the TDS in milligrams per liter in the rejected water. So they have asked us to find out the TDS weight of the TDS in the rejected is equal to weight of the TDS in the inflow minus the weight of the TDS in the outflow. We know that the weight of the TDS in the reject is 0.4 that they have given over here. I mean, 40% of the flow into the flow rate into the weight of the TDS in the outflow is equal to TDS in the inflow. We found out it is this value minus TDS in the outflow. We found out it is this value. If you do this calculation and divide it by this value, you will get the TDS in the reject. So go through this problem once again and also go through this practice problem in RO operation, which is given in the lecture material. This dealing with the similar methodology where they have given us the TDS and said that 75% of the 75% of the water is being treated and obtaining a permeate, that is rejected water of 60 milligram per liter TDS. So stay focused on the units and also again get familiar with the terms used in this permeate, reject, treated water, total water when it comes to the reverse osmosis. Like in the sludge thickening unit also, this is also a little confusing problem, but then if you do 2-3 of this, you'll get familiarized with the terms and the units, and it will be easy for you there. Moving on to the next question. It's having some
Sorry, I just went somewhere. Did you ask something?
no. I was just, I mean, my internet connectivity got a little unstable. Please hold on. I'll just open the slides to this part. Okay, so this is the next question. Consider the following unit processes. Codes have been given: RM for rapid mixing, F for flocculation, primary sedimentation, secondary sedimentation, chlorination, rapid sand filtration. For a conventional water treatment plant, specifically, this is for conventional water treatment plant. What is the order of these unit processes? Okay, Sangamitra said D. Okay, so yeah, the correct answer is D. First, there's primary sedimentation. After that, for the process of coagulation, rapid mixing units are used, and then flocculation happens. After flocculation happens, again it has to be kept for sedimentation so that the flocks will get settled down. After that, that water is then filtered through rapid sand filtration or any method of filtration, and then it is sent for disinfection, where chlorination is one of the disinfection methods. Next question. In disinfection, which of the following forms of chlorine is most effective in killing the pathogenic? We had again discussed this earlier. There are different forms of chlorine used for disinfection. So in that, out of this one, which is the most effective pathogenic killing disinfectant? Is it chlorine element, hypochlorite ion, dichloramine, or hypochlorous acid? Yeah, so it's the right answer. It's hypochlorous acid. The decreasing order of disinfectant in that in terms of the capacity of or effectiveness of killing pathogenic bacteria, hypochlorous acid is the most strongest agent. After that, OCl. In fact, hypochlorous acid is 80 times more stronger than OCl. Then only elemental chlorine, and after that only dichloramines are coming. So hypochlorous acid is the strongest form of chlorine in disinfection. Next question. Aeration of water is done to remove what kind of impurities? Is it suspended impurities, color, dissolved solids, or dissolved gases? Correct. The answer is D. It's dissolved gases. So you can see here, for suspended impurities, sedimentation processes used. For removing color, processes like oxidizing agents like copper sulfate and all are used for removing color. For removing dissolved salts, reverse osmosis processes like reverse osmosis is used. And it's for gases that process like aeration is used. So that is the answer for this question. Moving on to the last question. Pathogens are usually removed by chemical precipitation, sedimentation, activated sludge process, or chlorination. Answer is D. So chemical precipitation is used for removing very fine suspended particles. Sedimentation is used for removing suspended particles. Sludge process is for removing, for treating sewage, and chlorination is a disinfection process used for removing pathogens. So that was today's session on disinfection and other treatment processes like membrane-based techniques and oxidation-based techniques. That's all for today's session. If you have any doubts, you can ask. Otherwise, you're free to leave the session. Kiran,
Yes, ma'am.
you can stay back to, yeah. If anyone's got any doubt regarding the questions that we discussed today, you can ask doubts, or we can we'll end the session for today. Okay, so Kiran, what can you tell the question number which you had a problem with? 11, right? 0.22 meter per water water treatment plant for purposes. Okay, let me just check. Okay.
This is one question that I got wrong, and the other questions are similar. Matlab, mistake has happened. That I took the breadth and depth wrong.
Um,
Ma'am, if I am taking 4 meter as breadth, then I'm getting the correct answer. But
yeah,
if I
see,
take
actually, when you provide dimensions, if it is not provided, like length is equal to this much, breadth is equal to, the notation will be length, breadth, height. So 25 is the length, 4 meter is the breadth, 4.4 meter is the depth. So what?
okay.
So what you're saying is, when you take it like that you're not getting the answer, or you're when you take breadth is equal to 4 meter, are you getting the correct answer?
And you said correct. If I'm taking length, breadth, height, I'm getting it correct.
Yeah. So they don't have to actually particularly mention length, breadth, height. The notation is understood as length, breadth, height if the values are only given.
I saw some relations that where the second one was coming correct, that 4 will be depth. Somewhere it was there in the slides that
Where in the lecture materials or in the problems
lecture,
that we discussed?
lecture material. So that's why I did that.
No. I think by default, like in any kind of problems, if they are saying 25 by 4 by 4.4, it means length, width, height, or length, breadth, depth.
Is it question number 10 from assignment
Yes.
5? Or
Yes.
but particular thing is not mentioned. Only it is written that 0.22 meter cube per second of water is treated in water treatment plant with 4 clarifiers. Dimension of each clarifier is it is given 25 meter into 4 meter into 4.4 meter. Then what to find out exactly? You see question number 10 again.
Okay. You don't know what it is to
Yes,
find out. Point
it
2
is
is
not
treated in
mentioned.
water treatment plant with 4 clarifiers. Dimension of each clarifier is okay.
So as nothing is given, so whatever I thought as per the steps given in the solved problems, accordingly I have done something, but it is showing wrong.
Okay. I know that doesn't make sense actually. It's they have asked you to.
Somebody told something in the discussion actually.
Okay.
Where they told that what is the question, and I got it correct, I think. But what was the question even? I don't remember.
Let me
No,
just check.
nothing is given. Actually, what to find out is not given. That is
Okay.
the thing.
Let me just check the discussion forum as per what Kiran said. If there's something in that, probably, yeah.
The professor or somebody told what was the question. Somebody told.
Yeah. Let me just check. I'll give it to you. Detention time is the question asked in question number 10.
It was
Sangamitra, yeah, that is detention time that we have asked for question number 10. Actually, they have not mentioned it in the question, but I think that was some kind of error that happened when they put the question. The question they require is the detention time. You're supposed to find the detention time for in that
Yes,
question number 10.
as nothing is mentioned, so
Uh-huh.
as per the means whatever problems are already solved in the lecture videos. So as per the steps, I have done some calculation, but it is showing wrong.
Okay. Anyway, try just by using length 25, breadth 4, width 4, and height 4.4. And for the 10th question, you're supposed to calculate the detention time. Just have you already submitted it?
Mhm.
Okay. Whatever it is, even in future, just make a note of it that it is detention time when you're
I
practicing.
have done accordingly.
Okay,
But
okay.
as nothing is mentioned in question number 10, so
Mhm.
whatever I felt I did accordingly, so it is showing wrong. But other question, next question, it is showing correct.
Okay. Some I know. I mean, that's an error that has happened in the question. So regarding the doubt to what you have to take breadth and width, this will be the standard in most. I mean, unless they specify, it is always going to be length breadth width, length breadth height, or length width depth. Whatever. Okay, is there any other doubt?
No.
Okay. Okay, then Kiran, Sangamitra, and Alex, if there are nothing much you need to discuss today, we can end the session for
Ma'am,
yes.
there is one slide, design of sedimentation tank,
Okay.
module 5, lecture 26.
Just a second. Module 5, lecture 26.
Here, slide number.
Okay, which slide in lecture 26? Design of sediment.
Yes, primary clarifier.
Okay.
So here, as per CPHWO, rectangular tank dimensions, length by breadth is equal to 3 to 5 is to 1, and width is 6 to 10, and depth is 2.5 to 5. So if we want to take the 4 and 4.4 from here, so we will get at least one thing wrong, because width has 6 to 10 meters and depth है 2.5 to 5. So if we take 4 as width, suppose if I am following these guidelines, then I'll get one wrong, because width is going 6 to 10. If I take 4 as width and 4.4 as depth, I'll get depth correct. If I take 4.4 as width, again I'll get width wrong because of the guidelines. But the one you were saying, ma'am, if I do, it's fine. If you say I'll do it like that, I just
no. What happens is this design criteria. These design criteria are when you're designing a new tank without any available value. Say maybe you have the inflow rate and you're supposed to design a new tank. In that case, we should have a restriction to some dimensions that we can take, right? It is for this that they give the design criteria. But in questions, when they're specifying that you have this, you have this, you have this, you don't have to go think about what is the design criteria given. These values are only when you're designing a tank newly. If it is an entire complete design problem. They're saying design a tank according to CPHEO, which won't come mostly for our this one, but in case you need to do it as a project or something, this is the guideline you have to follow.
Mhm. But
I'm-
ma'am, I think
Yeah,
okay, I'll do it the way you said, but I
Mhm.
think they should have matlab, made the range higher for accommodating this answer, maybe.
Right,
Because,
maybe. Yeah, probably they didn't look into the values and all. It might just be for the
Mhm.
purpose of numerical.
No problem, ma'am. It's just few
Yeah,
questions.
okay.
Okay, ma'am, I think I'll we
Okay,
can wrap up.
okay. Thank you, Karan, for your conversation.